Using substitution here, we're going to take what one equation tells us and sub it into another equation, right? So what's this equation telling us? Okay?
That y equals 12x plus 3.
Yeah, so we know what y is supposed to be. Looking for what?
Fruit or like food, right?
Food? None.
Okay.
Okay, so it's telling us what to replace y with. It is telling us y is quite literally 12x plus 3. So this y right here, okay, maybe I'll color code it with, like this y right here, and this y. Remember what we were saying from, not even just from last class, but the end of the class before that, I highlighted the fact that this y and this y are what? What's that?
The same.
The same. Right, maybe you heard equal. Something else like equal. They're equal. They're the same. These two, I made them both green to kind of drive home that point. They're both the same. So if this y is the same as this y, and this y is 12x plus 3, then this y could be 12x plus 3. So we substitute exactly that. Okay. Make sure to distribute this coefficient to everything that is y. Right? Y is the same as 12x plus 3, so negative 1/3 should get multiplied by all of 12x plus 3. This equals 0. Okay, so we're going to distribute that negative 1/3, gives us negative 4x minus 1 equals 0. Is that okay? Is it too fast for you? Good. Distributing that negative 1/3. Good to go. Ready?
You could add 1 on both sides.
Okay, so Brady's just going to go for it here, adding 1 on both sides and combining these to make a 4x. Okay. And then x is what?
1/4.
1/4. Now we know what x is, we can figure out what y is. Okay? And if we're using substitution, you may have noticed this pattern. We solved for, say, x, and since we used an equation that told us what y was from the beginning, we can just go back to that equation, right? Y equals, plug in the thing we just found for x, and it'll tell us what y is. We'll plug that in, 1/4, positive 1/4. 12 times 1/4 is 3, plus 3. So y is 6, y is 6, plus 6 is 6. Okay. So the solution is 1/4 comma 6. Good? Questions? Okay. Red 17 is next. 17, okay. So there's a drama club. They earn $1,040. That's the total amount they earned. A total of 64 adult tickets. 64 adult tickets. And 132 student tickets were sold. An adult ticket cost twice as much as a student ticket. Okay. Adult ticket is twice a student ticket. Write a system in your equations or so we write some equations. Well, first we should probably determine what x and y should be, right? So x should represent something, y should represent something, and x should represent
X.
adult what?
Adults.
Tickets.
Tickets.
Right.
Money.
The price of adults. Price of adults. And so y would represent
Price.
price of a student ticket. Price of a student ticket. Okay. Let's see. Maybe we gotta be able to see this stuff. So we need to find two different equations to write. And one of the mistakes that people make when they're writing these equations is trying to put too much information, like all the information, into one equation. Okay. There's supposed to be two. You write one equation, in the second equation. Okay? So, if this is the price of an adult ticket and this is the price of a student ticket, there's no real easy way to do this. You gotta look at the information and figure out how can I roll all this information together into an equation, and how can I write a second equation based on what I'm told. Information about how many people showed up, how much money was made total, comparison between the two prices.
X to Y since Y is the student price and the double.
Okay, so the adult ticket is twice the value of a student ticket, right? So if X is an adult ticket, it should be equal to 2Y.
Yes.
Agree? Okay. I'll tell you, when I was learning to write these equations as a youngster, I would get this stuff backwards a lot. I was like, it's supposed to be X equals 2Y, but I put 2X equals Y. So you just want to double check and make sure that your equation makes sense with that statement. Okay, and it does, that's good. Adult ticket X equals twice adult ticket Y. And that kind of helps, like we've used some information like this information. Adult ticket is twice a student ticket. I don't imagine we'll probably need to use that again, right? So probably this other equation, we'll use information about the total money made, and information about how many adults showed up and how many students showed up. Put yourself in this situation, pretend you know how much a student ticket costs and how much an adult ticket costs. Right? How many students showed up and how many adults showed up. How would you use that information to find the total cost? How would you find, let's just concentrate on the adults. How would you find how much money you made from adult tickets? Monica, you have to take a shot at it. 64x. What do you guys think about 64x? 64. What's 64 have to do with anything?
Number of
Number
tickets
of
sold,
Number of tickets sold. And x is
how much it costs.
price of one ticket. We all agree, price of one ticket times 64 tickets. Total cost of all the 64 tickets together. Okay, we're starting to, this should start to roll us along here, Johnny.
132Y.
Plus 132y. I guess we could kind of assume plus, right? Should we plus them together, add them together?
Yes.
Yeah. They should come out to be, ready?
1,400. I mean, 1,400.
1,000. So the amount we made off adults, amount we made off of students, added all together should get the total amount. No money coming from anywhere else. That should make it out. All right, now we have two equations, and really, the next part should be pretty easy. Right? X is 2y. So what are we going to do in this equation? X is the same as 2y. So we just started, we're talking about substitution, and we're going to substitute, Grady?
2i for x.
2y for x. Right, so this equation has an x in it, and it's going to assume instead of x have a 2y. Switch colors. So 64 times 2y. I replace x with 2y, and that's okay, because x and 2y are the same thing. 132y equals 1,040. Okay, so 128y plus 132y equals 1,040. See, 260y equals 1,040. 5 by 260, and what does y come out to be? Don't be shy. Y'all have calculators. 4? Okay, 4. And if y is 4, then what's x? 8. It must be twice as much. So what does that mean, y is 4? What is it? Yeah,
That's how much the tickets cost
for who?
for the students.
Y is for the students, yeah, student price, right? That's good. That's what's nice and labeled to start with. Y is the student price, and the adult price is $8. And number 18. Y minus x equals 0. 2x minus 5y equals 9. So this is a situation where neither of the equations tells us what to substitute for something else, right? Neither of them says y equals or x equals. That shouldn't be a problem. We can rewrite one so that it does say that, okay? Maybe the hardest part here is deciding which equation to rewrite and what to solve for. But if you look at the equations and you see like a 1y or a 1x or even a negative 1y or a negative 1x, those are pretty easy to solve for. And as I look at the second equation, I could get x by itself, I could get y by itself, but not a very nice looking answer, right? I'd have to like add 5y divided by 2 and have times 5y over 2. That's not very good looking. But in that first equation, what could we solve for very easily in one step? If we add x to both sides, add x.
So x equals y.
Hardly be an easier substitution, right? Y equals x, x equals y, so either replace x with y or y with x. It doesn't matter. So 2x becomes 2y. Minus 5y equals 9. So 2y minus 5y is negative 3y. Equals 9. Y equals negative 3. Y equals negative 3, then what does x equal?
X equals
Yeah, because they equal each other, and x and y are the same. So negative 3, negative 3. If you did your homework and you came and you checked your work and you got half of them wrong, then you should make it a habit to check your answers. Make sure you double check your answer. Obviously, these two work in this equation, right? Negative 3 equals negative 3. Let's just double check it in this second equation. Color like orange. 2 times negative 3 minus 5 times negative 3 needs to be equal to 9. Negative 6 plus 15. Does that equal 9? 15 minus 6? It's 9. Yeah. Okay. So it's true. So we did it. We did find the correct solution, negative 3, negative 3. Alright, so notes getting down. Here. This one's set up nicely. The next one's not set up so nicely. Why is this one set up nicely? What's nice about it?
The y already equals something.
Y already equals something. Y already equals x minus 7, right? And so since y is the same as x minus 7, we're going to replace this y with x minus 7. Or x minus 7 times x minus 7, because x minus 7 is the same as y. It's 10, and so we distribute. X is 49. It's 10. Negative 3x. Let's subtract 49 from both sides. Negative 39 divided by negative 3, and x is
13.
Positive 13. Then we plug it back into this equation. 13 minus 7, y equals 6. 13 comma 6. Saw some little mistakes as I walked around. Saw negative 13. Little things like that. Alright, so this one's not as nice, it's not set up, it doesn't say x equals that or y equals that, we don't have anything to substitute yet, so we need to use one of these equations, rewrite it so that we can substitute. Someone other than Grady? Cadence?
Subtract y.
Subtract y, subtract y. So this equation becomes x equals negative 3 minus y, right? We don't have to use that equation anymore. Let's use this new equation, new and improved. X equals negative 3 minus y. So That's what x is worth, so we'll replace x with that. 5 times negative 3 minus y plus 2y equals 9. Distribute, we get negative 15 minus 5y plus 2y equals 9. These could all look better. We'll add 15 and at the same time collect these like terms. So we get negative 3y equals 24. Divided by negative 3, and y is negative 8. Plug that back in there. X equals negative 3 minus negative 8. That's negative 3 plus 8. So x is 5. 5 comma negative 3. Alright. Any questions?